Good morning, guys. Welcome back to FECAM's unique histology review series. This video is brought to you by the academic and editorial boards of the Federation of Catholic Medical and Dental Students, FECAM's unique chapter. Please do not forget to like our videos and subscribe to our channel, as this will encourage us to make more educational contents like this. So today, we'll be looking at the histology of the male reproductive system. So the male reproductive system comprises of the testis, the epididymis, the vas deferens, the prostate, the penis. We've actually described the penis in the last video on urinary system. So, but we'll still briefly look at it today again to solidify our knowledge in its histology. So let's start with the testis. So let's read the side notes. The testis can be identified by the presence of seminiferous tubules. Then the functions is the production of spermatozoa, production of male sex hormone. Development of the testis is from the genital tubercle or the genital ridge. The pathology includes the testicular torsion, orchitis. The spermatozoa in the testis extends from the base up into the lumen with varying degree of maturity. So this last lower note is one of the most important keys to identifying what the testis, this particular part, is the most important key to identifying what the testis looks like. So the testis is made up of basically connective tissue and seminiferous tubules. So, okay. So the seminiferous tubules are wrapped in an outer coat of tunica bugina, though it's not, we can't really appreciate it here. Okay. Now, these things that we can see in cross section comprises the seminiferous tubules. These things that we can see in transverse section comprises of the seminiferous tubules. And the seminiferous tubules are where the spermatozoa are made. Now, in between the seminiferous tubules, you can find connective tissue separating them. So there is also presence of cells called the Leydig cells, which are the interstitial cells. So they are found within the connective tissue. You also find the presence of blood vessels. So these hollow spaces here are the blood vessels. So you can't really appreciate much of the Leydig cells, but they are there. So you should take note of it, that they are within the interstitial tissue. Now, the testis is made up of layers of cells. The seminiferous tubules of the testis is made up of several layers of cells. And the key thing for differentiating the testis from other similar structures like the epididymis is the way the cells are layered. So you have layers of cells from the base of the epithelium up into the lumen. So you see spermatozoa at varying stages of maturity. So near the base, you will see two major groups of cells: the sustentacular cells of Sertoli, which serve as the supporting cells for the spermatozoa. They also provide nutrients for the spermatozoa and protection. You will also see the spermatogenic cells. That's the precursor cells. So they are more at the base. Then, as you progress towards the lumen, you see some spermatocytes and spermatids in varying levels of development. So that's one of the striking features about the testis. So due to the presence of these cell layers, it kind of obscures the lumen. This can be compared to what we find in the epididymis, where there is a clear-cut demarcation between the epididymis, between the lumen and the cell layers. So the cell layers kind of encroaches into the lumen. Look at this. Look at this here. Look at this here. So the lumen is not really clear. It's not too clear, unlike the one you see in the epididymis. So look at how clean the lumen of the epididymis looks. See that? See that? Same thing here. So the same thing can be said of here. These are the seminiferous tubules, numerous. So many of them in cross section. So you can also appreciate the basic features we've mentioned before. The different layers of cells at varying levels of development. And then you can see how obscured the lumen is. So the lumen is not really distinct due to the varying layers of cells, which also encroaches into the lumen. So in between the seminiferous tubules, you can find the interstitial cells of Leydig, the Leydig cells. So the Leydig cells, they are within the interstitial space. And also you can also find a few blood vessels, so many blood vessels. Those ones are not really clear at this point. So look at another slide of the testis. You see something that looks like it's a luminal organ or a luminal structure. And then you see cells at various levels of development. See this? See the way the lumen is obscured by the varying layers of cells in different levels of development. So the same thing can be said of this one, this one, this one, this one. I believe you can appreciate that. And look at this also. Let's zoom in. See the way the lumen is obscured in this one. Can't appreciate a clear-cut lumen. Look at this one too. Look at this one. So many of them on the slide. Same thing here. So the tunica abugenia is visible at this point. The tunica abugenia. Then the interstitial cells, which are in between the seminiferous tubules. And you can find a few blood vessels as well. Now the tubules contains different layers of cells at varying levels of development. and then the lumen is not exactly distinct. You can't find a clear-cut lumen due to the way that the developing cells obscure the lumen. So you can see so many of them. So I hope you appreciate that. Now the testis versus the epididymis. Let's read the notes. What are the differences? The sperm cells extend from the basement membrane, which is this, to the lumen with no sharp delineation. So you can't really say that this is where the layer of sperm cells end. Then Leydig cells in between. So Leydig cells are these cells that are in between the seminiferous tubules. And then you can find blood vessels as well. Leydig cells are found in between. Leydig cells produce the male androgens, testosterone. So versus the clear-cut epithelial lumen border in the epididymis. Now look at this. Look at how smooth this looks. So you can say exactly that this is where the lumen of the epididymis ends. And then you can see a few clumps of spermatozoa within the lumen, because the epididymis actually stores spermatozoa. So look at this also, clear-cut lumen. This one too, very clear-cut circular lumen, and so on. So that's it for the testis. So the epididymis, we've already explained it, but then let's throw more light on it. ID is epididymis. Reasons for identification: convoluted tubules lined by pseudostratified sterociliated columnar epithelial cells. So I encourage you to review our earlier video on epithelium, so enable you understand how a pseudostratified epithelium looks like. Okay. Secondly, there is presence of spermatozoa in some of the tubular lumen, so you can appreciate clump of spermatozoa. Then the function is storage of spermatozoa. Development is from the Wolffian duct. Then anatomical relation is the anterior part is the testis, medial, vas, deferens. Pathology is epididymitis. So look at this. You can appreciate the clear-cut lumen. And then this layer is a layer of pseudostratified sterociliated columnar epithelium. So these cells, they contain sterocilia that aids in propelling spermatozoa or mature sperm cells to the outside world. Same thing here, clear-cut lumen, clear-cut lumen, clear-cut lumen. Then there is also presence of smooth muscle cells, a few smooth muscle cells within the wall of the epididymis, though it's not very obvious here. See this one too, clear-cut lumen with a clump of spermatozoa within the lumen. Look at the clump. So you can appreciate the clear-cut lumen. And then you can also see a clump of spermatozoa at the center. So this is not like the testis, where the varying layers of developing spermatozoa obscures the lumen. Here you find clump of spermatozoa within the lumen. So clear-cut lumen as well. So this one too, appreciate the clear-cut lumen. This section is the transverse section, and then you can also appreciate the clump of spermatozoa, this deep staining structure. within the lumen. See this one too, this one too, this one too, this one too. So this one too. See the clear-cut lumen. That's a very striking thing about the epididymis. So these are connective tissue that holds them together, holds everything together. So that's it for the epididymis. So here they are comparing the epididymis and the testis. So you can appreciate the features, the basic features we've mentioned before. You can see the way the lumen is obscured by the varying layers of development of the spermatozoa. So many of them here. You can also appreciate the tunica abugenia. Here you can see the clear-cut lumen. Here you can see the clear-cut lumen. This is the epididymis, this is the testis. So this one is the testis, this one is the epididymis. So you can find the clear-cut lumen. This one contains a clump of spermatocytes. This one too, clump of spermatozoa. So I hope this has clarified the differences between the epididymis and the testis. Now the next organ in the male reproductive system is the prostate. So let's read the side note. Reasons for identifying the prostate is the presence of corporal amylase or prostatic concretions. So these are amyloid bodies within the glands of within the glandular part of the prostate. So you will also find those glands suspended in abundant fibromuscular stroma. So that's the second reason, abundant fibromuscular stroma. And then function of the prostate includes production of seminal fluid rich in acid phosphatase. So the development is from the urogenital sinus and the endodermal evagination from the prostatic urethra. So the weight is about 20 grams. And then the pathology is prostatic benign hyperplasia, that's BPH. Then prostatitis and also prostatic CA. So the prostate is a gland, but then the way it appears on histology is like a gland suspended in abundant fibromuscular stroma. And then the glandular part has this striking look of kind of serrated margins. So the margins of the gland appears serrated. So look at this. Serrated means saw-shaped. See this? See the way it is serrated? So most of these are the glandular part. Kind of appear serrated. And most times within the glandular part, you see eosinophilic material that represents the amyloid bodies, the corporal amylase within the prostate. Their function is unknown. So look at this too. You can appreciate the serrated margins of the glandular part. And then you can see some eosinophilic material within the lumen of the glandular part. This represents the amyloid bodies. Then you can also appreciate the abundant fibromuscular stroma. Very abundant. And then the way the glandular part appears serrated. So this is specific for the prostate. So you can also appreciate that here, serrated margins for the glandular part. Can you appreciate that? And then abundant fibromuscular stroma. Can you appreciate that? So the slide of the prostate is easy to identify. Also the same thing here. You can also appreciate the glandular part with serrated margins. You can also appreciate them, the glandular part with serrated margins. And then the abundant fibromuscular stroma. So the slide of the prostate is quite easy to identify. Glandular part with serrated margins. See that? See that? They are numerous. So this doesn't look like the testis or the epididymis. So the prostate is very distinct. So same thing here. You can also appreciate the glandular part with serrated margins. They are numerous here, suspended within abundant fibromuscular stroma. The glandular part with serrated margins. So it's quite easy to identify. Glandular part with serrated margins. See that? See that? So they are numerous. So that's it for the prostate. Now the next is the vas deferens. So the vas deferens is a muscular tube that conducts spermatozoa to the prostate and the urethra. So the reasons for identifying the vas deferens is the thin irregular mucosal folds. That's this, the tiny lumen, the thin irregular mucosal folds lined by pseudostratified epithelium, and then a thick muscular layer. Those are the two major reasons for identifying the vas deferens. And then the development is from the mesonephric duct. Then the length is about 45 cm. And then the function is for the transport or the conduit for spermatozoa. And then you can also appreciate the layer of connective tissue that surrounds the vas deferens. Can you appreciate that? Now, identifying the vas deferens is very easy because the lumen is tiny and it is lined by pseudostratified epithelium. And then deep to the epithelium, you find lamina propria, which is also part of the mucosa. And then you find the thick layer of muscles. See this thick staining area that is uniform. It kind of contains 3 muscle layers: an inner longitudinal muscle layer, a middle circular muscle layer, and an outer longitudinal muscle layer. So the muscle layer is really, really thick. And then connective tissue that lines it, in which you can find some few blood vessels. Okay. Now this is the vas deferens again. Notice the tiny lumen with irregular mucosal folds. Tiny lumen. So that's the specific appearance for the vas deferens. Then the thick muscular layer. Can you appreciate that? Same thing here. A tiny lumen, and then a very thick muscular layer, and then an adventitia. Can appreciate that. Same thing here. A tiny lumen with irregular mucosal folds, and then a thick muscular layer, and then a fibrous coat. So the penis again. So reasons for identifying the penis includes presence of corpus spongiosum and corpora cavernosa. So these are the erectile tissues. The corpus, the dorsal ones are the corpus cavernosa. This one. So the corpora cavernosa. since there are two. Then the ventral one, that's in normal anatomical position, is the corpus spongiosum, and you can appreciate the presence of the penile urethra within the corpus spongiosum. And then the classic monkey face appearance. So the penile urethra flattened in one axis within the corpus spongiosum. So the development is from the genital tubercle. The length is about 15 to 20 cm. Remember the transitional epithelium lining the penile urethra changes to stratified squamous epithelium distal to the navicular fossa. Then pathology is the penile fracture. So the penis is very easy to identify. The erectile tissues are covered by tunica abugenia. And then find the erectile tissue. So this is the classic monkey face appearance. So that's it for the penis. So the organs of the male reproductive system are quite easy to identify, and I hope this lecture has helped you understand the differences between them, the different parts. So this is where we stop for today. Drop your comments and questions in the comment section. In the next video, we'll look at the female reproductive organs, the histology of the female reproductive organs. Thanks for watching.